Namaskar. Welcome to the AMD Epic Cloud Chronicles, the Hindus podcast that explores how technology, particularly cloud computing technology, shapes society. AMD is a recognized market leader in high performance computing technology at a time when many businesses are moving to the cloud. That's a responsibility AMD takes seriously and is strengthening its commitment to drive data center innovation now and into the future. I'm your host Pankaj, and today we are diving deep into the evolution and the future of cloud computing, a term known to a lot but understood by a few. Joining me today is Professor Indranil Gupta, a professor of computer science at the University of Illinois. Professor Gupta leads the Distributed Protocols Research Group in the CS department at UIUC. His expertise lies in research of distributed systems with specific focus on large-scale distributed systems such as data centers, cloud computing systems, IoT, and distributed machine learning. So let's get right into it. Professor Gupta, in fact, life in computing or in control systems has really evolved over the last 3 or 4 decades. Probably we had control systems with the likes of PLCs, the SCADAs, the distributed control systems, which were very hardware oriented. In the last 2 decades, probably software has taken over, cloud technology has really done well. So, can you walk us through the evolution of cloud computing over the years and some of the key milestones according to you?
Sure. Thank you for having me on this podcast. It's a very exciting time to be in computing in general, but definitely in cloud computing as well. And you mentioned SCADA systems, and we can come back to that. In a sense, there is a lot of connection between SCADA systems and cloud computing today because things like power grids are being connected to the cloud. Um, but going back a little bit to the history, back in the 60s and 70s, in the very early 1960s and 1970s, very early days, right after the transistor was invented, there were these very large scale processing centers, data processing centers, and there was a fairly significant sized industry, about $70 million or so, which went up a little bit, mostly based in the US, where you'd have these large data processing centers. You'd take in, packs of punched cards, which would have your program on them, and then you'd give it to the assistant. The assistant would say, come back in 3 days. And you go back in 3 days and you'd receive these printouts of the outputs of your program. Those were the very first large scale data centers.
Right.
Since then, we went through the revolution of personal computers, PCs with the Windows in the 1980s, then smaller scale clusters in the 1990s, kind of peer-to-peer systems in the 2000s, and then we have come full circle back today to data centers, but in a very different
Yeah.
way. We don't have punched cards anymore. You can write code and you can deploy it right away in the cloud. The cloud is accessible to literally anyone who has a credit card and can pay. Sometimes you don't even need that. If you're inside a company, the company often has its own private cloud, and you can access that without even having to pay because you're an employee of the company. So in a sense, it's very interesting to notice that history kind of repeats itself, and that's true in computing as well. So what used to happen in the 60s and 70s with the data processing industry, we have come full circle with that, but very different technology, very different use cases. The cycle of software is a lot faster than it was back then, but a lot of similarities persist back to what happened in the 60s and 70s.
Yeah. Professor Gupta, now, in fact, as evolution happens, decade wise decade, things become a bit more complex. The requirement or the use of cloud infrastructure for any business becomes much more complex. But I guess research and industry probably should be going hand in hand. So, how do you think research can probably be used to kind of uh, get some solutions to the challenges in cloud computing?
Right. Yeah. So typically, in the early days of cloud computing, I would say mid 2000s or so, when the large companies, including Amazon Web Services and Microsoft Azure and Google Cloud came out, the typical way to deploy your applications was by virtualization. So you would run virtual machines, which would essentially be small sandboxes that are running an OS, whether it's Linux or Windows or whatever, and you could run multiple instances of those. Later, those virtual machines got replaced by containers, which are kind of lighter weight virtual machines. That's the right way to look at them. But essentially, instead of buying your own cluster of, say, 1,000 machines, which would take millions of dollars or crores of rupees to purchase and maybe months to get and then install, and you'd have to pay a lot of people to manage it, you could simply spin up 1,000 virtual machine instances within minutes. So this saved time, it saved money, and it saved a whole bunch of other resources. And that's kind of why cloud computing
Hmm.
became popular in the very early days. Since then, I would say in the last 10, 15 years, since 2010 or so, a lot of different ways of using the cloud have emerged. So it's not just virtual machine instances. You can actually kind of take your large scale program and break it up into parts and have each part be essentially its own application in the cloud. And in that way, you can scale up each part. For instance, if I have let's say, a make-believe application where I have a user service which manages user accounts, I have a separate service that manages
Yes.
posts, like a social media thing, right? And let's say the user service doesn't really need much scale, but during the middle of the day or during something as interesting as the ongoing Olympic Games, you might have a lot more posts come in. So I might need to give more resources to the post service. I can scale that up, just the post part itself, without scaling up the users part. So those kinds of new modalities have emerged. So they go under different names such as microservices or serverless
Right.
offerings. There are offerings from these cloud providers, but essentially it allows you a lot more flexibility in scaling up or managing individual uh, parts of your application rather than treating the entire application as one, or what we call as monolithically. That has made the cloud computing environment a lot more richer. It's allowed companies and use cases
Correct.
inside the company's applications to be designed in very nimble ways, but it's also introduced a lot of complexity because now you have to deal with not one application, but all these different moving parts. And if you have five moving parts, there are now five different ways in which things could go wrong. So that also introduces new challenges in there.
Very interesting, Dr. Gupta. In fact, you mentioned about a lot of interesting aspects when we spoke about research, because research and academia, that is, and industry probably ideally should be having a very symbiotic relationship. I mean, they're dependent on each other, and it's a kind of a helpful situation. So, how do you approach solving real-world problems in distributed systems, and what role does industry collaboration play in research? Now, you have been part of various such kind of collaborations, so if you could share some of your experiences.
Yeah, and in fact, I think that's one
Hmm.
of the very nice things about cloud computing, that there is a very close synergy between academic research and industry research. I'll describe a few ways in which it happens today. So, of course, there is some
Correct,
part of
correct.
academic research that's called as blue sky research, where they say, okay, I'm going to kind of ignore what industry does. I'm just going to imagine a world where I can reshape the way in which the cloud stack looks like, and I'm going to do research on that. There is some part of that. Then there is some part of academic research which works on real problems that are motivated or come out of industry. But these are longer term problems. These are problems that industry right now does not have the bandwidth to solve because it's not a short term problem. It's more like a 2 year or even a 5 year time frame of things.
Hmm.
And so academic research can actually help a lot there because we can go off and spend time and have graduate students and faculty and researchers work on these things, which companies know and they say that they cannot work on right now because it's not a part of their immediate, whatever, 6 month vision itself. So a lot of research in academia and also in research labs, like if you talk of research labs like Google Research and HP Labs, they work on a lot of these like medium term and long term projects as well.
Dr. Gupta, now let's come to the real world. A business is all about profits. It's all about the performance. So, how does a business choose the right solution for their cloud computing requirements, particularly with reference to performance? Because performance is directly related to profits. Profits is directly related to the business. So, how do you think a business should go choosing the right solution?
Right. So that's a very difficult question, and that really depends a lot on what kind of application you want to run in the cloud. And there are a lot of different modalities, right? So oftentimes, companies, especially startup companies, they kind of start out small. They might run services in the simplest way possible on the cloud. They might just use VMs or the simplest way of doing microservices. But over time, it kind of grows, and they can make it more appropriately complex as they understand the ecosystem a little bit. Because the cloud is a very complex ecosystem, and it's kind of like, if I ask someone to swim and threw them into the deep ocean in the middle of the Mariana Trench, they're probably not going to make it. And then after a while, they can say, okay, this part feels comfortable, so maybe I'll go to the deep end of the pool, and after that, the ocean. So I think that really has to be the approach, right? And I'm simplifying the analogy a little bit, but I think that's really has to be the approach. Start simple, and read the documentation. I think there is a lot of documentation that's available, a lot of use
Correct.
cases that are available. I'll give you an example. So a few years ago, we worked with Microsoft. My research group worked with Microsoft. Um, in kind of exposing the internals of their microservices framework. So Microsoft has this very interesting microservices operating system called Service Fabric, which is a major part of their revenue.
Hmm.
And a lot of services run on Service Fabric. For instance, if listeners have a BMW card, the BMW Connected service runs on Microsoft Service Fabric. A bunch of other, like internet televisions run on Service Fabric. But the Service Fabric design itself is very complex and very interesting. And while working with Microsoft and writing the paper, we
Right.
came across all these different use cases that had built applications on top of Service Fabric, and a lot of these are public information. So there are blogs that describe why they moved to microservices, how they moved to microservices, and in some cases how and why they moved back away from microservices back to the original VM based approach. So I would say companies should do their homework, and read a lot of these blogs and see what experiences are there, which ones of those experiences match well with their specific use cases,
Right.
and then use that as a starting step, start small, and then kind of grow from there.
Quite fascinating. Quite fascinating. Now, businesses, Dr. Gupta, now they always would look forward to upgrade or scale, because you start with a particular infrastructure for your business, then your transactions, the aspects of business become more and more complex. You need to kind of then increase your cloud computing infrastructure. Probably many companies, probably at a time in a year, they want to get into a digital transformation. So businesses who want to upgrade to better cloud computing infrastructure, and probably they're looking for digital transformation. Does processors powering the virtual machines or clouds machines like AWS Cloud, Google Cloud, or Microsoft Azure, how important does hardware become, the processor become, in this case when you want to upgrade?
Absolutely. I mean, they're very critical, and especially in this day and age where machine learning applications are, everywhere. You have to have cloud offerings that offer GPUs, graphics processing units, general graphics processing units, so that machine learning training as well as inference loads can run on them. But also, you cannot run a machine that has only GPUs. You have to have a machine that actually has good processors, host end processors that can interface with the GPUs.
Yeah,
There
yeah.
are ways in which you can split your machine learning application between the GPU and your host end processor. So a powerful host end processor and a flexible and expressive host end processor is very, very important in those cases. And of course, there are applications that are not machine learning at all. There are more traditional enterprise
Hmm.
application that require these processors. It's very interesting thinking of processors because until maybe like the late 2000s or so, there was this law called the Moore's law, which was very active, which essentially said every 18 months or so, the processing speed, the gigahertz that you got in a processor would double, and that was correlated with how much transistors you could put on a square inch of die. When you have reached some level of density of transistors on the die, you have to spend a lot of
Right.
energy cooling the die itself. And so that energy is essentially equal to the benefits that you get from putting that. So it hit what is called as a power wall. That's what we call it as a power wall. So since the 2010s, what has happened is that instead of scaling vertically, instead of making these processors more and more powerful and higher frequency, machines have started offering more numbers of processors. So now you have scaling, I don't know if it's every 18 months or so, but every couple of years, the number of processors you can buy per dollar or per rupee kind of doubles, loosely speaking. You can buy offerings which have multiple virtual processing units, virtual CPUs, multiple GPUs, and the cost of that is also kind of coming down, kind of at an exponential pace, like I described. So in all of that, I think the quality of the processors that you get is going to be very important from the provider side. The more expressive the processor you have, the more expressive can be the offerings that are provided from the provider side. For run-of-the-mill customers, it may not make much of a difference. Just the basic instruction set that you have and everything else might just be sufficient. But there are a lot of niche customers that have very specific requirements from the instruction set itself in the processor. And for those customers, it's going to be very important to have processors that can
Correct.
actually offer those specifics. And in particular, I think the machine learning era in the last 5 to 10 years has brought in a lot of demands from not just the GPUs but also from the host side processors
Right.
itself. And I think that's where a lot of the new upcoming processor architectures are trying to innovate.
Dr. Gupta, now, whenever we talk about businesses, it's about performance, it's about profits, it's about the hardware, it's about the software, but then costs are the most important aspect for a business. So, how can companies effectively manage costs while scaling their distributed systems and cloud computing resources? Now, this is the most important question. Probably a lot of our viewers and listeners would want to hear from you.
Nearly everything we do today, whether it's in India or in other parts of the world, runs on the cloud. So when we go out there and call an Uber or an Ola or variants thereof, that is not running only on the mobile device. That request that we send is going to an Uber application that is running in the cloud. The driver's side is also communicating with the Uber applications. Once you sit in the car, the rideshare car, whether it's Uber or Ola, the tracking of the car and everything else is also running in the cloud. And so that's just one example, right? Essentially, banking services, financial sector services, I think all of them have benefited a lot from the cloud in reducing the cost, right? So instead of running your own buying, procuring, and running your own little cluster, you can now outsource everything to a cloud provider and
Right?
essentially rest easy at night that if something goes wrong with the machines, then there is some other company there taking care of it and will bring the machines back up. And you're not going to be called at 3 a.m. Because a bunch of servers went down in your own private cluster. So there is a lot of peace of mind. Apart from just the cost saving that comes from the cloud, there's also peace of mind from knowing that there is a company that is running fairly large infrastructure. Um, but of course, that comes at the cost of not having full control of these machines, right? So in some cases, especially highly secure applications, which are like banking or transactional applications, you may need more control over the hardware, and that you're not going to get from the cloud as it is. So the cloud computing infrastructure and ecosystem has been around for what, like 20, 25, 30 years or so, depending on how you count. Some might say it's been around for 50 years. It's a very mature infrastructure. There's a
Yeah,
lot of research
correct.
going on it, and you can reduce costs on it. But let's say we stopped research completely on the cloud computing in academia and industry, things would not collapse completely. Things would, a lot of things would still run. Um, where there are the more exciting, what we call as edge computing, where that's the interface between the cloud, which is a set of data centers and machines inside the data centers, and the other devices that are out there outside these data centers. An example of that is, of course, farms that you mentioned. Another example is smart homes. Like in homes today, increasingly, both in the Western world and in India, We have smart bulbs, we have smart devices, smart TVs. These have processors. We have cameras, smart cameras, and things like that. And all of these devices are communicating with services in the cloud. So there is a lot of very interesting and exciting research problems
Right.
that involve these devices that are kind of out there. They're a fog, they're an edge, they're not your traditional definition of cloud computing, but in a sense, they are tied to the cloud. So everything you want to do with the devices, whether it's program them or to just look in on the camera, that, hey, what's going on in my home? I'm on vacation. I want to see, who rang my doorbell. Everything has to go via the cloud. The same thing is true of even more emerging domains, like you mentioned, of agriculture, where farmers in the West, in the Western world, in the US, farmers have to manage fairly large farms, many acres of farms, and it's impossible for a single farmer to manage the entire farm by themselves. So now they install sensors and robots which communicate with each other, but also communicate with services in the cloud. In India, the ecosystem is different because the farms are smaller. There's a lot more population density. It's more rural, but some of the same problems arise. Whether the problems are devices communicating with each other and coordinating, or whether the challenges are from the network being very slow, because after all, you have to rely on just your cellular network
Right.
and 5G, and also there's some emerging networking technologies there as well, which are being brought to the fore in both those areas. But though there, I think there is a lot of very interesting challenges, because it's kind of like you talk about devices and you have to handle challenges with the devices, but you cannot only focus on that. You have to also think of the fact that these devices are communicating with the cloud. So for instance, if a company comes along and says, hey, I have a digital agriculture stack and all my devices in your farm are going to send all the data to the cloud, that is not going to work, because your network is not fast enough, your network does not have enough bandwidth, and the cloud does not have enough storage, and you're going to spend a lot of money just storing all the data. You want to be processing the data as it's being generated on the sensors very close to the farm, and only send the insights to the cloud, right? So there's a lot of very interesting pipeline aspects there, which you don't come across when you're doing only like pure cloud computing.
Right.
This entire notion of edge computing, I think, extends the cloud, but also requires us to think in very different ways, and requires companies to think in very different ways. And there's a lot of very interesting companies that are emerging in that space, both startups as well as very large companies, the blue chip companies that are getting involved in the smart home space and in the digital agriculture space, and many other spaces that are involved in edge computing.
So, Dr. Gupta, in fact, a lot of sectors have started using cloud computing. Generally, we know banking, finance, UPI transactions, e-commerce, all these areas, they are definitely using cloud computing, and that's getting more and more complex. So, in what way do you think has cloud computing transformed modern business operations? Because particularly in the Indian market, we were still kind of, working towards it. Could you kind of also tell us some notable success stories or case studies, probably how can these kind of cloud transformation infrastructure has helped the Indian market?
Yeah. Yeah. So as we discussed before, cloud computing has been kind of maturing for the last 20, 25 years or so. And a lot of the infrastructure is already in place. And there's a lot of work that's going on still on the reliability, safety, security aspects, and scalability aspects. And I think newer ways of building applications will continue to emerge, beyond microservices, beyond serverless. That those are the ones that we've discussed today. Tomorrow we may see new ways of managing applications that are more fine grained. But really, one of the newest emerging trends has been, as you and I and literally everyone else who is familiar with the tech field knows, has been AI, artificial intelligence, and machine learning. That has kind of revolutionized both enterprise applications. It's also revolutionized user side applications, when we are using Amazon Alexa at home, or whether we're using Siri on our phone, or whatever other voice assistants on the Android devices. All of them rely on some form of natural language processing. Literally every company that processes data uses AI or ML now. And at the end of the day, all of this AI or ML applications, they all run on the cloud. They all need access to the cloud to train, right? So AI is only as good as the training data, but in reality, AI is only as good as the infrastructure that exists to train the model with the data itself. And all the infrastructure is sitting in the cloud. Um, as AI models and ML models and machine learning models have become larger and larger, we've gone from smaller models that used to do very task-specific things to more general models, which are called as foundation models nowadays. Foundation models are a very important part of the large language models, LLMs. ChatGPT is something that many listeners may be familiar with. And all of those require large amounts of infrastructure to train the model, but also to do inference when the queries come in. When I speak with my colleagues who work in the large firms that run large cloud services, one of the common trends I hear is that even inside the companies, the demand for cloud computing resources to train machine learning models is far more than the companies can supply. So the companies are actually struggling to keep up with the internal demands inside the companies themselves. So forget the external demands from the public cloud. Even the private cloud inside the company, if you're an employee, you usually have a lot of resource requirements, and the companies are often struggling to keep up with the resource requirements. Which is what explains why the chip makers like GPU chip makers are having a heyday in the stock market, and they're having a really good earnings reports nowadays, and because the demand is a lot more. So I think that is going to change quite a bit how the cloud itself is built. The offerings in the cloud will change so that they're more attuned to these machine learning workloads, so that it becomes easier to build machine learning applications. The developers can build applications so that the training can be done easier, the inference can be done easier, can be built easier, and can be run easier, right? So you can build applications today, but then once the application is running, debugging it is very hard, and that of course requires some more software infrastructure on the cloud computing side itself. Um, the other thing that is different apart from the technical aspect is that because of the large language models today, there is a lot of hype on them. That the large language models are able to achieve a lot of things that we were not able to achieve just 4 or 5 years ago. But oftentimes, managers in companies large and small have unrealistic expectations of what large language models can achieve. So there's a gap between what large language models or LLMs can offer and what the reality is on the one hand, and then what managers think they can actually offer. And so I think bridging that gap really requires managers and technicians and developers to continue reading up on the field of machine learning and machine learning systems, because it's a very fast moving field. A lot of research results are coming out from academia and from industry and from research labs. It's one of those areas where companies are actually publishing. They don't publish the models, like OpenAI doesn't publish models, but they publish a lot of the research results underlying that research. It's a large volume. It's really drinking through the fire hose, as the American phrase goes. It's a lot of information. But I think there are very interesting blogs, very accessible blogs that people write that kind of summarize that information. So I think it behooves us and folks in industry, including managers, venture capitalists, and everyone else, and CEOs and CTOs, to keep abreast and keep up to date of what's going on in the machine learning field, so that they can anticipate the changes that might come in the cloud and might come in the machine learning systems field in the next few years.
Really, really interesting. Dr. Gupta, in fact, while reading about you, we came across certain things that you seem to be using music to teach complex computer science concepts. Now, you do have a musical look. I don't know whether it's you have done it purposely or it's a natural look or something like that. But music for teaching complex computer science concepts, that's something really very interesting. How creative approaches like this one do you think will enhance learning in technical field? For example, I've known of Dr. Manjul Bhargav, the field medalist mathematician, who is a fantastic tabla player. He has written a book on math in music. He's using those concepts. You have been using those concepts. So how has been that entire what do you call experience of using music to teach complex science concepts?
Right. Yeah. Thank you for bringing up the music. It's definitely a passion of mine. I've loved playing new musical instruments, picking up new musical instruments since I was a child, growing up in Hyderabad. A couple of things I do. I One of the things I do is I compose small music videos where I sing, and sometimes there's a performance aspect associated as well. And there's a YouTube channel. If people are interested, they can go to the YouTube channel, Indie Gupta. You can find a lot of my videos there. But essentially, I take algorithms that you might teach in class, techniques you might teach in class, and put them into song so that it's more accessible to students. And the students that I have who are online in my Coursera class range from really young in their teens to really old in their 60s and 70s who really want to move inside the tech field itself. So it's a very large range of students. And to make technology, cloud computing, machine learning systems accessible to a wide range of students from very different backgrounds. Not all of them have computer science degrees. Many of them have never taken a computer science class in their life, but they want to know more about cloud computing. To make it more accessible to them, music is a great leveler. It brings people in. It kind of draws your attention. It's a good hook. I also host in the US. I also host a radio show that has nothing to do with my work. It's a radio show on a local community radio station there where I play music from all over the world. So music is certainly a passion of mine, and I think at the end of the day, technology. We sometimes those of us who are in the field for many years, we think of technology as very compartmentalized. It's like, okay, there's this part of my brain that deals with technology, and everything the rest of my life is all separate. But in reality, the human brain is just one thing. So the more we can create associated memories in our brain between the technological aspects on the one hand and other things that we enjoy. I think everyone enjoys music. The more the associated memory is, the better the learning is. So at the end of the day, I think the educational benefits of music are very underappreciated and very underrealized in the tech field itself. So that's something that I've been trying to innovate and grow on. And I hope that, we can do more and more in the future. I think the students love it, I try many different musical instruments. Recently, I started rapping as well, and the students,
Oh,
I
wow.
I did a rap song recently just to kind of motivate my students to do better projects in their class. And I didn't expect that to take off, but the students loved it. And I don't have any quantifiable evidence, but I certainly saw a lot of students kind of, improve their projects after they heard their song. So maybe I'll do a little bit more of that. It's a very interactive thing for me. So what works for the students motivates me as well, and then it's there on YouTube for everyone to see.
So, friends, speaking of innovations, today's episode is sponsored by AMD Epic, Processors Cloud Computing Solutions. Organizations demand scalability, flexibility, and performance to support the growing complexities of cloud workloads, from popular enterprise applications to transaction processing and AI. While migrating to the cloud has provided IT leaders with flexibility and simplicity in how they manage their resources, it has also caused a rapid increase in cloud computing OpEx for many. Finding a way to maximize resources without expanding the OpEx is the key success, and choosing AMD-based VMs is a way to reach that goal. Cloud VMs powered by AMD EPYC processors are available from leading cloud service providers, Amazon Web Services, Google Cloud, and Microsoft Azure. You can also visit our website, that's www.amd.com. Dr. Gupta, thank you. Those were really encouraging words, very, very interesting inputs that you gave us regarding cloud computing, technology, evolution, challenges, and much more. So, friends, these were just a few examples of how cloud computing is shaping modern businesses, particularly in India. Dr. Gupta, thank you very much for sharing your insights with us today, and it has been a fascinating conversation. We hope to catch up with you very, very soon. Thank you very much.
Thank you for having me.
And to you all listeners, thank you very much for tuning into this episode. We hope you've enjoyed exploring various facets of cloud computing with us. So don't forget to check out our website www.amd.com for more information. Until next time, let's keep exploring the fascinating world of cloud computing. This is your host Pankaj Athavale signing off.